כשאני מדבר, אני צריך להסתכל על פה על המחשב שלי. Welcome everybody to We are so happy to meet all of you here, and I hope you have interesting, informative, and joyful time here with us in the next video. I want now to start to give you a short summary about the company profile. Right now, we are already for 24 years in development applications. Our branches are all over the world. There are 2 offices in Israel. In Europe, we have Cytecam GmbH. In Germany, which has 7 offices. And we have affiliated companies, Cytecam UK, Cytecam France, Cytecam CZ, Cytecam Iberica, and Cytecam Italy. In the United States, we have Cytecam Incorporated. In the Asia Pacific region, we have Cytecam Japan, Cytecam India, and Cytecam China. And affiliated companies in Asia Pacific are Cytecam ANZ, Australia and New Zealand, and Cytecam Singapore. In addition, we have a worldwide CAM distributor network of more than 70 resellers. Let me give you a little more in depth about Cytecam GmbH. It was founded in 1994, so it has already 24 years expertise in CAM sales in Germany. And as I said, Cytecam GmbH has 7 offices. You see here the locations: Schaumburg, Rosenheim, St. Pierre-Watt, Gummersbach, Suhl, Worms, Houston. The fact that we have 7 offices here in Germany give us access to our customers and give our customers access to us. Totally, we have 75 staff in Germany for sales and support. One point I would like to mention that we are so strong in the educational market that the VDW, which is an organization for vocational training, decided to have a training book for CNC using SolidWorks and SolidCAM. And all the young people today studying CNC and CAD/CAM use this book for their study. Cytecam GmbH has, in addition to having 7 branches, has a very nice technology center. Here we see a picture of the technology center with our first machine, Hermela C30 5-axis CNC machine. The second machine that we have in our technology center is the DMG NTX1000 multi-turret, multi-spindle machine, and we use it to benchmark for midterm, and it's a very nice machine in terms of its multi-spindle, multi-turret capability. In the US, we have also a technology center in our headquarters in Newtown, Pennsylvania. We have in the US 30 staff for sales and support, and the machine we have in our technology center is a Hilco BM10i. Our major distributor in Japan, Tactex, their headquarters is in Nagoya, Japan. They have 10 additional branches in Japan. You see them here in the map. Tactex has also a technical center in Gifu. And let's see the machines they have. They have a DMG Mori DMU50, a Mori Saiki MV5000, and an OKK VCX500. Cytecam CZ is working together with Solid Vision in the technology center they have with a Hermela machine in the Czech Republic. And it's a Hermela C20U CNC machine. All these centers that have technology CNC machines are able to teach CAD/CAM and technology to all potential customers, and the machines can be used also for benchmarks and for creating examples to show the different types of cut. So it's a very good capability to have your own machines to demonstrate and check your capabilities. Now that we got an overview of the company, let's look now at our newest product. It was released a couple of weeks ago, SolidCAM 2018. I will try to go through the main highlights of the product. Let's start first with very nice changes in the user interface and automation. We have now a very beautiful capability called drag and drop. You see here on this picture on the right is a task pane with a list of operation templates, and the user can with a mouse drag one of these templates to a surface in the model, and automatically this operation will be activated on this geometry. You'll see it soon shown by Sid. We can also drag and drop the template not only to the model but to the CAM part manager directly. The same thing that we do with regular templates, you see here on the right, in the task pane. On the top, there are templates. On the bottom, there are process templates. So the same thing that we can do drag and drop with operation templates, we could do with the process templates. We could drag the process templates either to a surface in the model or directly to the CAM manager. And the last of these capabilities, and the most powerful, is you can now drag and drop an existing operation to the part to create new operations. This is really beautiful, and Sydney is going to show. Okay, and this capability will be in SP1. Okay, Sydney, go ahead.
Okay, thank you very much. Come on. There we go. Okay, as Emil said, we have made major improvements also in our interface, and also the use of made it a lot easier to use, such as the drag and drop, as Emil had mentioned. As far as the interface goes, we have in our task pane the capabilities of actually entering our operations or parts directly from the task pane instead of going what we used to do with in tools, SolidCAM, and then start looking for what we need. We have that now in our task pane over here, as well as in our CAM tree. We also have the capabilities of opening up over here, or recent parts, save as. All of these improvements were made in our interface at this point. Now, let's get to drag and drop capabilities. If we take a look on our task pane for drag and drop templates, we have operation templates as well as process templates. Let's first start with our operation templates. Let's say I'd like to put an iMachining operation on this area over here, on that particular face. What I do is I'll take, let's say, an iMachining operation. Say we'll take one that I have over here, this template. And I'm just going to drag it onto that face. The moment I do that, the operation is being created, and then we have a tool pass automatically created on that face as well. I can do this with a pocket operation as well. Let's take, for example, a pocket operation. Okay, and we'll drop the pocket operation. I can also have this way. I'm going to drop it onto this face over here, and there we have a pocket operation inside over there as well. Now, I can also do this to say these faces over here, but these faces, instead of dropping into each one individually, I like to have it, all of these in one operation, not just separate operations. So when I drag and drop an operation to the face, if I hold my control button on my keyboard, I'll just let go of my mouse, and while I'm still holding that control button, I just click on each one of these faces. The moment I'm done, I just let go of the control button, and then we have one operation for all of those faces, as we see over here. Now, let's do, for example, another operation, such as a face operation. I'm going to do a face mill operation for, say, the top over here, and you'll see that it puts a face mill operation on top. Now, one other note, I'd like to put one on this face, okay? And you see right now I've been working the whole time Mac 1 position 1. What happens if I drag it to that face over here? What happens is as follows. It'll create another home position as well as create that operation on that new home position that we have over there. So we're also creating home positions automatically as well as putting it in the right position. Now, let's take another part that I'd like to show you, because I also like to demonstrate the use of process templates. So let's say I have a part that looks like this, where it has many pockets. You'll see that in a moment. And I'd also like to do a face mill operation on top. As we see over here, we also have our process templates. And as we click on each one of those, you can also see what each process template has inside of it. So for example, I'd like to do, like I said, a face mill and a pocket recognition on that part. You see I have those two operations there. I'm just going to take this and drag it onto the part itself, and it's going to create that face mill operation as well as the pocket recognition operation for that part. You can see that being built right over here, right in front of our eyes. Okay, now I've shown this on 2.5D operations, but what happens if I have something for 3D? So let me load this part, and let's first start with HSS. Now, I like to put an HSS operation on this surface over here. And as we know, when we have HSS and doing it on the surface can actually go towards several home positions, not just the one going up towards the top. So what happens in that particular case? If I were to drag and drop an HSS operation to here, it'll ask me which home position I'd like to work on. And I can choose from the different home positions I may have over here. I'm just going to leave it at Mac 1 position 1. And when I accept that, it'll create the operation. Now, what if I use an operation for HSS that has more than one element that's needed for the geometry, such as a parallel to curve operation? So I'll just drag that template over there as well. Let me just reload the part. Ooh, Zelatov. So what if I take an operation that has more than one element, such as the geometry of the face, and I need an element for parallel to curve? So when I drag and drop that particular operation, again, it asks me which home position. I'll click on OK. It'll create the operation and open up the operation as well. So this way I can just add the geometry that needed, which is a particular line, such as this one over here. And all I have to do now is just calculate, and I have that operation as well. Now, as I said, we also do this for not only for HSS, we also have this for iMachining 3D as well as HSM. Let's just show this for HSM. If I were to take an HSM operation and drag that to the part, it'll create the operation, calculate everything, and there we have everything done in one simple drag and drop according to the template. Now, let me load a different part. And this one is actually one of the newest features I've added inside SolidCam. And as Emil had mentioned, this is called drag and drop operation. This will be available in SolidCam 2018 SP1. Now, let's go away from the templates for now. I don't want to even look at the templates now. I have here an operation, two operations actually, and you can see the iMachining operation is on that top pocket over here. And if I were to go into my coordinate system manager, you also will see I only have one home position. Now, what I'd like to do is I'd like to take this operation and have it on this pocket as well, also on this pocket. So what can I do? I can actually take the operation itself, drag it to that surface, and it'll create the operation over here. And I can also take that and drag it to this surface over here as well. And it'll create the operation over there as well. Okay.
Okay, let's continue. So we showed you now a very nice user interface. Another important feature that we always try to improve is cluster function. We have done very important change in this area. We have now an optimized geometry database. And this database goes for the geometry association. Now, I don't want to go into detail of how to optimize the geometry database. It's complicated. But the thing that I want to mention is as a result of having this optimized geometry database, we have a major increase in performance in opening and closing medium to large files, in feature recognition, in saving of compounds, in finding a large number of holes on faces or sketches, and in building chains on faces and sketches. All these features have been speeded up to tremendously due to optimized geometry. Let me show an example.
Sure, no problem. Okay, let me close this part. And the first thing I'm going to do is I'm going to open up a part that has the traditional way of creating the geometries that were done on it beforehand. And what I'd like to do is the following. I'm going to take someone, Beck here, for example. Please look at your watch. And when I say go, start taking the time and tell me how long it's going to take to actually open this part. And we'll start right now. And it's going on. This will take some time. This is the classical way of the way we used to the previous way that we used to create parts with the I'm not going to go technically into exactly what's going on over here, but as you see, this part, when you'll see it in a few moments, has many faces to it. And it would always take a long time to open up those faces, open up all the geometries involved. And as you can see, already we're at about 45 seconds. Is that right, back here? Yes, you're right, Sydney. And you'll see that it's going to take a little bit of a while. Now, what I'm going to do when I finish this is I'm also going to open up the exact same part that was done with the new optimized geometry creation. Okay, right now we're at a minute and 10 seconds. And don't worry, it won't take too much longer. minute and 15, still not done, and now we're done. A minute and how long was that back here? Minute and 20 seconds. Okay. Now I'm going to close this part, okay? And also closing this part used to take some time. And when I open the other part, you're going to take time again. Okay, so just a moment, we'll let this close. Now we'll be opening up the exact same part that we see on the screen, but that part that will be opening, the part that will be opening now is a part that we had already converted to the new optimized geometries. We'll show this in a moment again. This will be a good time if you need to drink something, you can do that too, or take a bite in your apple. Okay, so let me go now. Almost done, it's still closing actually. Okay. Now I'm going to open up the part again, but this time I'm going to use the new optimized system, okay? And we'll start taking our time. Becky, you're looking to watch again. We'll start now. And as you see, don't blink because this is going to go pretty quickly, I think. And we're at stop. 10 seconds. Wow, that's a big difference. You can see that this part, you can see it had all of these holes in it, and still it only took 10 seconds to open up the part. As you can see also now I'm closing the part, you can see how quickly the part closed as well.
Okay, now after beautiful new geometry, optimal geometry database, let's go to see what is new in SiteCAM 2018 regarding 2.5. Actually, we added something that people have been asking for as long as I remember, that our milling tool should take care not to hit the fixture. And we have done it. Finally, we have done it. There is fixture collision perception will allow you to safely count defined fixtures. And this is available in 2D 3D, also in pocket and pocket recognition. The profile below.
Also
in pocket and pocket recognition. And we've added also a nice option, cut only the rest material. And this is active in both pocket and pocket recognition. We've cut only the rest material. You can use the same geometry from a previous operation, and the tool will only cut the areas that have material left to cut. Okay, so show us how we're going to have the milling in hand.
Okay. So let me go again. Oh, I love working this task screen. Really makes it so much easier. I'll go open up another part. And let's first start with what Emil mentioned, what we have in our drilling operation. Now, in our drilling operation, I'm not going to actually create the operations. I've already done that, but I'll show you exactly what we've done here. We have two things. First of all, let me just show you that I've already machined away all this material that's in this area over here. I'll do a quick simulation just to show you that. All the material that we had around over here was milled away already. So the stock right now is actually all the way down to these areas over here. It's important because what I would like to show you now is the following. When I open up my drilling operation, let me first show you my actual geometry. My geometry includes all of these holes. As you can see, these holes are very close to the clamps. It also has holes that are underneath these clamps, and it has walls in between these holes over here. Okay. Of course, I've defined my tool. Now, if I go into my level, the first thing we've added over here is you'll note that my upper level, it says automatic or auto. This is because the milling upper level will be going according to what the updated stock was. So since I already machined the pocket, all these areas all the way down to there, the upper level in these cases will start from here. Now, if I go into my technology, we've added, as Emil had mentioned, we've added fixture collision protection. And we've also added the field of fixture clearance as well. So I can make sure it doesn't get that close to the fixture. We all know with clamps, sometimes, I'm not gonna go, it's too technical, sorry. We also added another option of shortest distance, to have the tool path go its shortest distance between one hole to the next. Let's take a look at the simulation. And I'll do this, use this solid verify. And let's do this one step at a time. You'll see it'll go down to that surface over there, start drilling over here. When it comes up, it'll go directly to the next hole without going to the clearance level. Drill that hole. Now it jumps above the clamp, goes to that hole, stays down to that hole. Now it's going to jump over the wall to get to the next hole. And the same thing as it goes along over here, jumping over that wall, that area over there, staying down, jumping over that short wall and not doing that drill that's underneath that clamp. And then does the same thing throughout the entire part. Okay, now let me just show you one more thing on this part, is what happens if I didn't machine out that area. And all I'm going to do, just suppress this first option, and I'm just going to go in here and just recalculate. That's all I'm doing. If we take a look now at the simulation, you'll see that the drilling now starts from the very top instead of going down every single time. Still jumping over the clamps, but this time it starts from the very top on each one of those. So that's where the automatic upper level goes from. Now let's open up a different part. And we'll show this happening in a pocket operation as well. We'll show the option of rest material and, of course, the issue of fixture clearance. Okay, if we take a look, I have here two different setups. My first setup has clamps over here. And my second setup has clamps on this side over here. Okay. So what I'd like to do is I'd like to create a pocket operation in this area over here. So let me go into my 2.5D operation. Just one of a few times I'll actually be creating an operation. And first of all, I'm going to create my geometry. Let's do this very quickly on that face. And we have here fixture collision protection, as well as the option of cut only the rest material. Okay, I'll just quickly add a tool. Okay, and I'll just make sure my technology is correct. Of course, I could have used a template as well. Let me just calculate. And as you can see, this area where I had the clamps was not machined. Okay, because that was done my first setup. Now, what happens if I were to copy that operation? Just do a simple copy and go to the next setup and just paste it there. No changes were made in the operation, and all I'm going to do is just calculate that operation. What you're going to see is as follows. It's only going to work in the areas where the previous operation could not machine because there was a clamp there. Now in this setup, there's no clamps there. It machined only in that area. And that's what the rest material does. Okay, I mean.
Okay, thanks. Next, we go to few nice changes in our major technology items. We have added the possibility to create floor fillet and machining 2D. A very nice feature Sydney is going to show.
Looks a little different.
Also, when there is a multiple chains, we have added the capability for each chain to be able to define a different upper level and depth. This is quite useful in the future. And the major thing we added in this version is the multi-tool. Till now, there was never a possibility inside SolidCAM to define more than one tool in one operation. Now this technology type multi-tool breaks this rule. Here we can define several tools in the same operation. And the geometry levels will be synchronized between the operations. The rest material is tracked automatically, and you can easily define wall and floor finishing per tool. Also, this multi-tool works in 2D eye machining and also in 3D eye machining.
לא, אמרתי שאין טעם, מבחינת טכנית, זה ממש מאוד טכנית. Sure, no problem. Okay. Let me open up a new part. Okay. We're going to show this very simply. And I took a simple part. You can actually see the radius here that we have. I have here right now a 3 millimeter radius. Now, if I were to go into my eye machining operation, let's go into eye machining 2D. I already have a geometry that I'm going to be using. This one over here. And if we take a look further down, we have here an option called floor fillet. If I were to use that, we have the radius of 3 millimeters, and I can control the size of the steps by scallops. So let's put a scallop of, let's say, 0.2 millimeters. I'll quickly add an end mill. And I'm just going to do save and calculate. What you'll see is very simple. My little mistake, I forgot to put the levels in. We're going up to there. I'm only human. Okay. What you see is as follows. If we take a look at the toolpath, you can actually see the radius being formed over here by the toolpath. Now let's go into another operation, and I'd like to work on this area over here. And I'd like to do 3 separate operations of eye machining on this pocket over here. So first, let's go into eye machining 2D. And if you take a look at our technology, right now it says iRough. If I were to open that up, we have here now the option of multi-tool. When I do that, it'll allow me actually to use several tools. First, let me add a geometry. The geometry is going to be, as I said, that area over there. And when I go into my tools area, you can see now we have an option of adding different tools. I'm going to select my first tool. My first tool, say, is going to be a 16 millimeter end mill. And in this particular case, I just wanted to do a finish. I'm not going to check off finish wall or finish floor. You can do that right here, but for this tool, I'm not going to do that. My next tool is I'm going to be using, say, a 10 millimeter end mill. And that I'll be doing my wall finish. Now I can add a third tool, and I'm going to use an 8 millimeter end mill. And with that tool, I'm going to do a floor finish as well. And you can see that with each one of these tools, I have them listed over here. And I can see the information for each one of these tools as I click on those tools. And if I go to my technology wizard, you can see each tool has its own settings for the wizard. As well as my technology, you can see my first operation. You can see all of the options that we have. First operation, only roughing, and then later on we have our finishing operations. Now when I do save and calculate, you'll see that we have 3 separate operations that were created within one operation. So within one operation, we use 3 different tools, and 3 operations were created from that one point. By the way, this is also true for iMachining 3D.
I'm not going to go into details about what are specific
שכחתי להקליט את הקטע האחרון, שכחתי להפעיל אותו.
because after my lecture and Sydney's lecture, there will be 2 lectures that will explain in depth our real-time improvements and strategies. But the only thing I want to say is that right now, SolidCAM has become one of the leaders in real-time. When we were leaders in milling with iMachining, and now we are leaders in real-time, and I hear this from everybody using our real-time that it is much stronger and easier to use in our company. You see here on the screen examples of machines that can now support Billiman 508 MT, NTX 2000, Citizen SL20, that's the Swiss type, Integex 200. So, Sydney, show us just quickly an example of a mill-turn part, an advanced mill-turn part.
Okay, in fact, and now I'm going to show you just a plain old mill-turn machine. What I'm going to do is I'm going to show it to you on a Swiss type machine. I'm going to show you the simulation on a Swiss type machine. Okay, so let's open up part. מה קורה פה? אוקיי. כן. אני רוצה להגיע לאחד שהוא די יציב, וכן. אוקיי. Okay. What I'd like to do is actually show machine simulation of this part on a Swiss type machine. In this particular case, this is a Citizen SL20. So let me go into simulate, and I'm going to use the machine simulation. Okay, let's put this off to the side. And as we see on this machine, we have our two turrets, okay, our two spindles. We have our front and back spindle, as well as all the different turrets we have over here. We have this over here. We have this one over down over there, this one on top, these over here, as well as tools on this side over here. So it's a pretty complex machine when it comes down to it.
Pretty complex.
Swiss type machine. So let's take a look actually at the simulation itself, and we'll start. And as you can see, right now it's working in this area over here. You can see actually the material going in and out the whole time, whereas the tools are standing still. But you can also see that we're also working on this other side as well. So we're working on both at the same time. You can see that the turrets now working in the background, everything working, moving back and forth on the parts, creating this part on the Swiss type. This is one of the more complex machines that we actually support, and we support very nicely inside of SolidCAM. Oh, okay.